god. What am I gonna do? This makes no sense. It's even 2 a.m. and I still don't get how to do calculus. Like, all of it. When am I ever gonna need this in the real life anyways? Like, integrals and derivatives? When am I ever gonna need that? Like, oh my god, I hate this. I heard you're having trouble applying calculus to the real world. Well, guess what? I'm the ghost of calculus, and I can teach you how it applies to the real world. So, you want to take a trip with me? I mean, if you can teach me calculus in one night, then I guess I'll go. But otherwise, like, why even go? Don't even worry about it. We're gonna go back in time so that we can spend as much time as you need learning how calculus applies to the real world. Our first stop is in downtown Denver, and our second stop is in Boulder. So, let's go! Here we are on the edge of downtown Denver. It's literally right there. I am on the Platte River. Behind me is this bridge, and if you went further back, you'd get to Beach Gardens. So why are we here? I brought you here to explain to you how calculus applies in our real world. You see, when this bridge was being built, there needed to be a blueprint for it. So that means it was just area because it was just 2 dimensions. But for some reason, it's 3-dimensional, and I can see it, I can walk in it, I can feel it. How does calculus explain that part for us? You see, one of the main parts about calculus are integrals. When you take an integral of something, in this case it would be our area, you raise its power. So we go from the squared to cube, so that would give us our volume. In creating this bridge over here, you need to take the integral of the area, of the function, of the bridge, and you would get the volume of the bridge. In order to create the bridge exactly, you have one big function, which would be our big semicircle, and a lot of small little functions subtracted from it while you're taking that integral. Welcome to Boulder. This is our last stop in me teaching you how calculus applies to the real world. You see, up until this point, everything that I've told you about calculus has been about man-made objects, like buildings, bridges, cars, toys, you name it. It was designed as a 2-dimensional object. It had its integral taken, and you found the volume. In this case, however, I'm explaining to you how calculus applies to nature. You see these mountains behind me, or these trees, or even myself? If you were to flatten us out, make us an area, we'd be an extremely complex piecewise function. If you took the integral of that piecewise function, you'd end up with our volume once again. Meaning that every single little thing that you see around you in the real world is technically just a complex piecewise function. And if you were to take the integral of those piecewise functions, you'd end up with their volume. Meaning that calculus is really all around you. And when you look at everything very closely, think like a mathematician, you'll realize that calculus is an amazing, wonderful thing that explains how we manage to exist in a 3-dimensional plane and not a 2 or 1-dimensional plane. Whew, that was a trip. But at least we're back now at exactly the same time, so it's like nothing ever happened. I do hope, however, that what I taught you helps you understand calculus just a little bit more and maybe even have a newfound love for it. But for the time being, because you don't need help anymore, I'm out, so peace.